In this video, we're going to talk about deriving the difference identity for cosine. So in the lecture part of this class, I wrote down cosine of a minus b equals cosine of a times cosine of b plus sine of a times sine of b, and I just said, boom, here it is. And so one way to deal with that is just to say, okay, I believe you, and we're going to move on. But I'd like to spend some time showing you how that formula comes about and how we know that that formula is a legitimate formula. And so what I have pictured here is I have a unit circle, and on this unit circle I have a bunch of drawings, and the overarching idea is that I would like to convince you that this line segment of QS and this line segment PR are exactly the same length. Okay, so I'm going to try and walk us through how we can see that is happening. And so the first thing that we want to do is we want to create an angle A, which is this really big angle, the one that starts on the x-axis and ends in the most open angle that we have. So the terminal side goes through that point P. And so this is our angle A. And since this is a unit circle, that point P on the terminal side of A, the x value is the cosine of the angle and the y value is the sine of the angle. So point P, the x value is cosine of A, the y value is sine of A. Okay, another angle that we create in this drawing is angle B, and angle B starts on the x-axis and has its terminal side pointing toward point R. So this is an angle whose measurement is B. Okay, just like point P, I can describe R, this point over here at the end of angle B, x value cosine B, y value of sine B. Okay, now I'm going to erase a fair number of these lines. Let's get rid of a lot of these drawings here, and we're going to recreate the measurement. Here's B, and here is A. Now, this other blue line that is drawn here, the one that goes from O up to Q, let's outline that one in purple. So O up to Q. Okay. That line is created by first starting at the very left. Let's do this guy. By starting here on the very left side over where angle A is, and then subtracting off the same opening as angle B. So if I create an angle of A, open it all the way up wide to A, and then drop back clockwise an angle of B, then what is left over is an angle that starts at the x-axis and ends at OQ, and that angle is angle A, take away B. So the point Q up here on the circle has as its x value cosine of A minus B and the y value of sine of A minus B. Okay, so now we have all of these angles drawn on here, and I hope I've convinced you that P, Q, and R have their coordinates that are drawn there. So let's erase some of this stuff, and let's look at a blank slate. All right, the next thing I'd like to convince you of is that if I look at, let's use green for this one. If I look at the angle that starts at S, goes to the origin, and ends at Q, that angle has the same measurement as the angle that starts at R, goes to O, and ends at P. And that it kind of makes sense, because if you look at the angle, and I'm using my hand here, but if you look at the angle of SOQ and you kind of take that angle and you rotate both pieces, then it lines up exactly with that purple angle that is here. So I'd like for you to, if you want to, pause the video and convince yourself that angle SOQ is exactly equal to angle ROP. And if you believe that those two angles are exactly the same, then that means that these diagonal lines that are cutting across the openings of those angles, those diagonal lines are also going to be equal, which means that the segment PR is equal to the segment QS. Okay, so if you can convince yourself that the segment PR and the segment QS, those two diagonal or two dashed lines that we have exactly the same length, then that is the key to this whole calculation that we're about to do. All right, now something else that we need is the distance formula. So in college algebra, you might have studied the distance formula, which says if you have 2 points, x1, y1, and x2, y2, then the distance between them is the square root of x2 minus x1 squared plus y2 minus y1 squared. And we're going to use that. So first thing we want to do is we want to come up with a formula or we want to come up with an expression that describes the distance from S to Q. All right, so SQ, its length, I can get by knowing that I've got this point 1, 0, that's our point S, and I have this point Q, which is cosine of A minus B, comma sine of A minus B. And so if I think of that point S as our x1, y1, and I think of Q as our x2, y2, then our length, or the distance between those 2 points, is x2 minus x1, so that's cosine of A minus B minus x1, which is 1, that quantity squared, plus y2, which is sine of A minus B, minus y1, which is 0, and that quantity squared. And then I take the square root of the whole thing. So now we have an expression that describes the distance between S and Q. We also want an expression to describe the distance between R and P. And so when I look at the length of RP, the 2 points that I have are, I have the point, point R, which is the point cosine of B, sine of B, and I have the point P, which is cosine of A, sine of A. So we have our x1, y1, and our x2, y2. So cosine of B, sine of B, that's our x1, y1. Cosine of A, sine of A is our x2, y2. And so our length of that line segment is going to be, x2 minus x1, so that's cosine of A minus x1, which is cosine of B, squared, plus y2, which is sine of A, minus y1, which is sine of B, squared, and then I want to take the square root of that. All right. Now, since our two sides, two segments are exactly the same length, that means that I can set the formula for length of SQ equal to the formula for the length of RP. So I'm going to go ahead and do that. So I'm going to write that down here. I've got cosine of A minus cosine of B squared plus sine of A minus sine of B squared, that whole thing square rooted, equals cosine of A minus B minus 1, that quantity squared, plus sine of A minus B minus 0, quantity squared, and that whole thing square rooted. So now I have this huge long equation that is a true equation that says that one of the line segments has exactly the same length as the other line segment. And if I squint real carefully at this equation, some things that I notice going on in this equation are I notice that I have a cosine of A minus B in this formula, or in this equation, showing up right in the middle. So our job is going to be, for the rest of this calculation, is to take this equation and solve this equation for cosine of A minus B. Okay, we are ready to solve this equation, and our job is to solve for cosine of A minus B. Now that guy is embedded pretty far into that expression. The first thing we can do is square both sides, and if we square both sides, then we get rid of those square roots. And that's going to leave us with cosine of A minus cosine of B squared plus sine of A minus sine of B squared equals cosine of A minus B minus 1 squared plus sine, well, this last one we have sine of A minus B minus 0 squared, so I really don't need to write that minus 0, which means that I can put the square directly on the sine function. So we have sine squared of A minus B. Alright, now looking at what we have remaining, we have three different terms that are being squared, and what we're going to want to do is to expand each of them. So let's start with cosine of A minus cosine of B. So cosine of A minus cosine of B squared is equal to, okay, this means that I need to write down cosine of A minus cosine of B times cosine of A minus cosine of B. And I want to distribute, so I'm going to take cosine of A and multiply it times both terms in the second set of parentheses. So I have cosine of A times cosine of A is cosine squared A, and then plus cosine of A times cosine of B, and then I'm going to take the negative cosine of B and multiply it through the parentheses. So we will have negative cosine of B times cosine of A plus cosine squared B. Now the two middle terms are the same. Oops, and you know what? Both of them, I made a mistake. Let's see, that guy right there, when I did cosine of A times negative cosine of B, that should have been a minus sign. Okay, so what I end up having here is cosine squared A, and then I'm going to combine the two middle terms because those are equal even though they're in the opposite order. They're both the same as cosine of A times cosine of B. So I have minus 2 cosine of A times cosine of B, and then plus cosine squared B. Okay, so we have now expanded that first term. Our next one that we want to look at is we want to expand sine of A minus sine of B squared. And I would encourage you to pause the video and expand this out on your own and see if you come up with the same value. Yeah, go ahead and pause that video. It's a good idea. Okay, so writing this out, we have sine of A minus sine of B times sine of A minus sine of B. And we're going to distribute just like we did up above. Sine of A times sine A is sine squared A. Sine of A times negative sine B is minus sine A times sine B. And then we have negative sine of B times sine A, so minus sine of B times sine of A. And negative sine of B times negative sine of B gives us plus sine squared B. Okay, so this is going to clean up to give us sine squared A minus 2 sine of A sine of B plus sine squared B. And in our final expansion, we are looking at cosine of A minus B minus 1 being squared. And so that is cosine of A minus B minus 1 times cosine of A minus B minus 1. And you should double check that when you distribute and combine your like terms, that what you end up with is cosine squared of A minus B minus 2 cosine of A minus B plus 1. All right, now we have all the terms we need. Let's put this all together. All right, we are ready to put everything together. So our equation on the previous page started out with cosine of A minus cosine of B quantity squared, and we expanded that out to be cosine squared A minus 2 cosine A cosine B plus cosine squared B. And then our next term was sine of A minus sine of B quantity squared, and we expanded that out to be sine squared A minus 2 sine A sine B plus sine squared B. Then we had an equal sign. Our third term that we expanded out was cosine of A minus B minus 1 quantity squared, and that gave us cosine squared A minus B minus 2 cosine A minus B plus 1. And then our last term that we didn't need to do any expanding on was sine squared A minus B. Okay. So looking at what we have now, there's a lot going on here, but at least we've gotten rid of all of the squaring of groups of parentheses. Here's where stuff starts to get kind of cool. All right, so take a look. If you squint a little bit, you'll see that we have inputs, or we have arguments that are A's and B's. But what I see is, I see a cosine squared A, and I see a sine squared A. So I'm going to put those next to each other. Cosine squared A plus sine squared A. And I also see, I see a cosine squared B and a sine squared B, so I'm going to put those next to each other. And the remaining pieces on the left side are minus 2 cosine of A cosine of B minus 2 sine A sine B. And then on the right side, what I notice is that I have a cosine squared A minus B and a sine squared A minus B, so I'm going to put those next to each other. So there's my cosine squared A minus B plus sine squared A minus B, and the leftover pieces are minus 2 cosine of A minus B, and then a plus 1. Alright, we're getting there. I see a few of the best trig identities going on here. We've got cosine squared A plus sine squared A, that's equal to 1. Cosine squared B plus sine squared B, that's equal to 1. And on the right side, cosine squared A minus B plus sine squared A minus B is also equal to 1. It does not matter what the angle or the argument is, as long as it's the same argument for the cosine squared and the sine squared term. Alright, things are starting to look a little bit better. On the left side, those two ones, they combine. 1 plus 1 gives us 2. So we now have on the left side 2 minus 2 cosine of A cosine B minus 2 sine A sine B. And on the right side, we've got a 1 and we have another 1, so those add together to give us 2. And then minus 2 cosine of A minus B. Alright, awesome sauce. This equation is getting smaller. And remember, our overarching goal is to solve for cosine of A minus B. Okay, I see I've got a 2 on both sides, so I'm going to subtract 2 from both sides. So 2 minus 2, those guys are going to cancel. And we are left with negative 2 cosine of A cosine of B minus 2 sine of A sine of B equals negative 2 cosine of A minus B. Alright, looking at the left side, I see I have a common term of negative 2, so I'm going to factor that out. So I factor out the negative 2, and I have cosine of A times cosine of B. When I factor out the negative 2, now I have a plus sine of A times sine of B. And on the right side, I have negative 2 cosine of A minus B. Alright. I can get rid of those negative 2's by dividing both sides by negative 2. And what I am left with is cosine of A times cosine of B plus sine of A times sine of B equals cosine of A minus B. And that, my friends, is exactly our difference identity for cosine. Cosine of A minus B is equal to cosine of A times cosine of B plus sine of A times sine of B. And now you know where it comes from.